In this video we're going to look at some questions from exercise A in our notes on converting Cartesian complex numbers to polar complex numbers. We have question 1 and question 4 here that's been requested. So question 1, we'll deal with that first. We're given a complex Cartesian and we have 4 plus j7. So we have 4 is our real number and j7 is our imaginary number. Now we always know that when we're dealing with any of these, we must use a diagram to help us. So I'm going to start by setting up our Argand diagram just very roughly. Draw something like this. This is our Argand diagram. We have our real axis. We have our imaginary j, so it's known as an Argand. Our center point, and it's plus, negative. So now we want to try and plot this Cartesian point on it. So by plotting that, we very simply know we have 4 as our real number, so we go out a distance of 4, and we'll say roughly 4 is out here, and we go up a distance of 7, and this isn't really to scale, but sure, let's say that's 7 plus 7. So point must be up here, and we can draw a phasor. So that is our point for j7. And then from that we have this phasor, which is going to be used to help us convert to polar. So I can make a right angle triangle from that. You see this right angle triangle I get developed here. Right angle in there. We have an angle. We now have a length that we can find. We know that this height over here is going to be 7, and this length here is going to be 4. So it's 4 along the real axis, 7 along the top axis. And we can use our trigonometry rules then to go find the values for that. So let's pick a color here. Well, we know r squared equals, just a squared plus b squared. So or, which we're trying to find, or equals square root of 4 squared plus 7 squared. So or is going to equal square root 16 plus 49, or equal square root square root of that's 65, so or is roughly 8.06. Then we can find theta, and we use our relationship. Well, we know our SOHCAHTOA, and we know tan of theta is going to equal opposite over adjacent. The opposite is the 7. The adjacent is our 4. So then to get theta, we manipulate that formula and we say theta equals the inverse tan 7 over 4. And when you put that into the calculator, you should get 60.3 degrees. And very quickly, if we do very quickly for number 3, we just have a real number. So when we plot it, we're just going to have a line along here. There's no imaginary number, so it's not going to create an angle. So you'll see we won't have an angle, and we'll just have a length, which just is 3. So it'll give you your polar answer. So I'll sketch that up really quickly and we'll come back. Hang on. So you'll see now that we've plotted that, we just have 3 along the real. So it doesn't make an angle because it doesn't have an imaginary part, so we get no angle. We have no right angle triangle. We just have a length of 3, and then we can express both answers in our polar form just like that once we have modulus length, the hypotenuse, and an angle.